Hello everyone, welcome back to MAC1140. So last time I introduced conic curve, and the first two conic curve we already discussed about were the circle, and the other one is the what is that? The parabola. In this video, we continue with section 8.2. In section 8.2, we'll be discussing the last two conic curve. The first conic curve I want to talk about is the ellipse. Okay, ellipse. And the second conic curve is the hyperbola. So what is ellipse and what is hyperbola? On the first part of our lecture today, the first part of the video, I think I'm gonna divide into two separate videos. On the first video, I will be talking about ellipse. And what is ellipse? Do you remember when I introduced the circle and the parabola? I draw a cone, right? So right now I'm gonna draw another cone. Okay, so we have a cone like this. Okay, and ellipse is actually the intersection curve between a cone and a slanted plane. So we have a plane that cut the ellipse, but this plane is not horizontal plane, nor is it vertical one, but it kind of slanted. So it's gonna go through like this. So I try to draw the plane, and the slanted plane. So this is the plane. Okay, go through like this. All right, and cut the cone. All right, like this. And when it's cutting the cone, okay, when it's cutting the cone, it's intersect. There's an intersection part between the cone and this plane. This intersection part is an ellipse. So I'm gonna have the intersection part right here. There you go. It's an ellipse, something like this. Here you go. Okay. All right, something like that. So I can say that ellipse is the intersection part between a cone and a slanted plane. Okay, that's just a graphical definition of ellipse. Okay, but the mathematical definition of ellipse is ellipse is the set upon okay, in the plane, okay, in the plane, it is set upon in the plane, and the sum of whose distances, okay, from two fixed points, okay, and these two fixed points here we call that F1 and F2. This is actually the focus of the ellipse. Okay, the focus of the ellipse. Okay, So definition, this is mathematical definition of ellipse. It's a step point in the plane, the sum of whose distance from two fixed points f1 and f2. Okay. You know, when you read the definition, sometimes it's kind of very hard for you to visualize what it look like, but everybody know what the ellipse look like, right? But I'm sure that you guys don't know where the focus of the ellipse. Okay, so we're going to be graphing the ellipse so that we can draw the ellipse so that you can see where the focus is. Okay. All right. We have two different types of ellipse. One is horizontal ellipse, and the other one is vertical ellipse. So I will be talking about those ellipse first. Okay. So those ellipse will have. I will be talking about the ellipse which the center is the origin, is at the origin of the coordinate system, and then I will be talking about the ellipse which center is any point in coordinate system. Okay, so let's talk about the horizontal ellipse first. So a horizontal ellipse. Alright, horizontal ellipse. Okay. So horizontal ellipse. In this horizontal ellipse, the center will be at the origin. Okay, so I will draw a coordinate system. Okay. Excuse me. I will draw a coordinate system, and I will draw an ellipse. So this is y, this is x. Okay. So horizontal ellipse look like this. So I'm gonna have something like this. So I try drawing a perfect ellipse. Okay. All right. Something like that. Okay. All right. So this is horizontal ellipse. Okay. And we see that we have vertices here. Okay, I call this is A1, and this is A2. Okay, and over here is B1. Okay, hold up. Over here we will have B1. Sorry. Okay, so we have B1, and over here is B2. Okay. And the equation that represents horizontal ellipse, which the center is at the origin, is x squared over a squared plus y squared over b squared equal 1. Okay. So the center of the ellipse is right at the origin 0, 0. Okay. So we need to understand this. What is A and what is B over here? A is actually the distance from the origin to the vertex A1 and A2. Okay, it means what? It means that the coordinate of point A is nothing but negative A, comma 0, and the coordinate of point A2 over here is A, comma 0. And in this case, and what is B? Let's talk about B first. B is a distance between the origin to B1 and B2. So B2, the coordinate will be 0, B, and over here will be 0, negative B. Okay. Okay. So if you look at the picture right here, you see obviously that A is greater than B. Okay. So every time you have horizontal ellipse, we know A1, A2 is greater than B1, B2. Okay. Even though it's just a name, you know, you can name everything you want. But in this case, because I named this A1, A2, so A must be greater than B. Okay, A must be greater than B. All right. A is the value under X, and B is the value under Y. Okay. And A1, A2. Okay. A1, A2. Okay, A1, A2. I can say that it's on the OX, right? It's on OX. So okay, because A1, A2 is on OX, and because it's greater than B1 and B2, so I can say that OX. Okay, OX is major axis. Okay, it's major axis. Okay, okay. A1, A2 is major axis, and B1, B2 or OY is minor axis. Okay. Alright. And because A1, A2 is major axis, so the length of this major axis will be what? 2A. Okay, so if they ask you to find the major axis, you just need to multiply A by 2. Okay, and B1, B2 will be what? B1, B2 will be 2B. That's the minor axis. Okay, let me fix the line a little bit here. Here you go. Alright. Oops. Alright. So 2A is the major axis, 2B is minor axis. Okay. Alright. So in the definition, I also mentioned about the fixed point called the focus. So where's the focus in the picture? Focus is a point on major axis. Okay, so it's the point right over here. It could be any point. Well, it must be inside, of course. So I'm gonna say, what if I say over here is F1, and over here is F2, and I say that this is the focus of this horizontal ellipse. Okay. Okay. And the distance between the origin to F1 or from the origin to F2, okay, we call that the C value. Okay, we call the C value. It means what? It means that the coordinate of F1 must be negative C, comma 0, and the coordinate of F2 must be what? C, comma 0. And C is the distance between the origin to the point F1 or to the point F2. Alright. Other than that, we also have the relationship. We also have the relation between A, B, and C. It means what? It means that if we know major axis or minor axis, we can find C. Okay. If we know major axis and the C, we can find minor. If we know minor and C, we can find a major. And the relationship is, c squared equal to a squared minus b squared. Okay, so I'm gonna box this. Okay, this is important, and I box in the formula right here. It's important. Okay. All right. Other than the focus, with A and C, we can also find the eccentricity. Remember, in a parabola, the eccentricity is 1. Remember, but for the ellipse, the eccentricity is between 0 and 1. So 0 is less than E, less than 1, and the eccentricity E can be calculated as C over A. Okay, that eccentricity is C over A. It means C, value C over whatever the value under the X. Okay. And we also can find the directrix. Okay, the directrix equation, and we have two directrix equation for each horizontal ellipse, and the directrix equation will be the vertical one, x equal to plus minus okay, a square over c. Okay, a square over c. So I'm going to box this formula also. Directrix will be plus minus a square over c. So we have two vertical one. Okay, two vertical line. Okay. Let's go to the example. Example number 1. I just want to see if we may miss anything before we start our first example or not. So I already mentioned eccentricity, directrix, the relationship between ABC, the equation. Okay, for the ellipse with center at the origin, we already mentioned the major axis, the minor axis. Okay, anything else? We talk about the vertices. So look like it's good. Look like we don't miss anything. Right, let's jump to the first example. What if I have the equation like this? 4x squared plus 9y squared minus 36 equals 0. If you look at the equation like this, and you see that, I mean, it doesn't look like anything with the formula we have here, right? Okay, let me stop for 1 second to make sure that I'm really recording, because sometimes it's really lousy and it's not recording and we will be wasting time. So let me check one more time. It's recording. Yes, so it's still recording. It's good. It looks like what we have over here. It doesn't look like the form, ellipse form, right? We already learned here. It doesn't look like. However, actually it is. Yeah, we need to have one on the right hand side, right? So what you have to do is you're gonna add both sides by 36. Okay, then if you divide both sides by 36. Then you see that over here we have number 1. So if I divide everything by 36, okay, everything divided by 36, then what I have here is what? Over here is x squared over 9, right? Plus y squared over 4 equal 1, right? Is it in the form yet? Is it in the ellipse form yet? It looks like. But we need to do one more step. We try to bring it to the square form, right? We get this nice perfect square. So from here I can write 9 squared over 3 squared plus y squared over 2 squared over 1. And now it's actually is in the form. Is in the form. And we know for sure that this is horizontal ellipse because whatever under the x value, whatever under the x squared is always bigger. So over here a is greater than b. 3 greater than 2. Okay. When we're talking about vertical 1, okay, vertical ellipse, then whatever under the y square is greater than under the x square. But if we have a horizontal ellipse, whatever the number under the x square is always greater than the number the y square. Okay, so in this case your a is 3, okay, and your b is 2. It means what? It means that the major axis, the length of major axis will be 2a, right? Then will be equal to 6 units. The minor axis will be what? Will be 2b, then equal 4, right? Okay, will be 4. Alright. We can also get the c. C squared equal to a squared minus b squared. Then give you 9 minus 4, give you 5. Then your c will be plus minus square root of 5, which is makes sense because c represents the distance from the origin to f1, right? And we have both sides, so I mean we have two coordinates, f1 and f2. Okay, so we have the vertex, okay, vertex a1, vertices, okay, all vertices will be a1 coordinate negative 3 0. Okay. Okay. Actually, b1 and b2 over here we don't call the vertices. The vertices is just this and this. Okay. Then a2 is 3 0. We can write out a coordinate of b1 and b2 if you want to. Okay, if you want to, you can write them down. So some textbook they say that the vertex is just a1, a2. Some textbook they mention that all of them is the vertex. So I think you know, in my opinion, I think that b1 and b2 is the vertex too. Okay. But it depends on some pre-calculus textbook. Okay, it depends. All right. So I think I'm gonna mention b1 and b2 as the vertex also. So it will be 0, 0, 2. And b2 will be 0, negative 2. So just write out all 4 vertices. Okay. And we also have the coordinate of the focus. So f1 will be what? Will be negative 5, negative square root of 5, 0, and f2 will be square root of 5, 0. Okay. Alright. And we also can find eccentricity E equal to c over a. C over a will be what? So it should be plus and minus, right? let me see, we want to mention because it's between 0 and 1, so it cannot be minus, so we just take the square root of 5 over 3. Yeah, because eccentricity is between 0 and 1. Okay, cannot be negative. Alright. And we can also have directrix. Okay, directrix will be x equal to directrix. We have plus and minus, so plus minus we 3 squares, so in this case will be 9 over square root of 5. 9 over square root of 5 plus minus. Okay. All right. And you can do a quick sketch what the ellipse look like, you know, because over here there's 6, so I think I'm gonna use 1 2 3, so 1 2 3, so this is 2a, so it'll be 3, right? And the other one should be 2, so this is what the ellipse look like. So we're gonna have ellipse something like this. If you want to sketch it, maybe on the test I won't be asked you to sketch, but I might, you know, because Valencia does not use any proctoring system, so all the tests is taken home test. So I think I'm gonna ask you to sketch it, to graph it. Okay, so this is y. This is your x. So A1 right here, A2 right here, B1 right here, B1 right here, and B2 right here. Okay. And C is square root of 5. So square root of 5 is around. Let me take square root of 5 real quick here. So we're going to do 2.25. So 2.5 right here. 2.25 is about right here. So this is F1. And then this is F2. Okay, so that is the ellipse. Okay, this is the graph of this ellipse. All right. Let's jump to. Let me see. I can do another example. Let me see. Okay, how about this? Okay. Example number 2. Or I think we're going to introduce the ellipse that which the origin, the center is not at the origin first. Then we can write the equation. We can learn how to write equation later, or we learn how to write equation now. I think we should do the second example right now. Okay. Okay. Says second example. Alright. In this second example, I want you to write equation, okay, of ellipse. Okay. Which minor axis is on OY. Okay. Which minor axis is on a y and has a length equal 4. Okay. Period. This ellipse also has eccentricity. Okay. Eccentricity equal, okay, equal square root of 2 over 2. Alright, let's see how we're gonna do this problem. Answer. We know that the information, when you read the information, you must recognize right away this is the vertical ellipse or horizontal ellipse. Because right now we do horizontal ellipse, so of course the example I give you must be horizontal ellipse. Okay, and another information they tell you that is good. The minor axis is on a y. The minor axis is on a y, and it has a length equal 4. It means what? It means the minor axis has a length equal 4, means 2b equal 4. Right? The length of the minor, 2b, okay, equal 4. So b equal 2. b equal 2. What else we have? We have that E, eccentricity, is square root of 2 over 2, and because this is the minor axis on OY, I mean this is a horizontal axis, so the E must be what? Must be what? The formula we already learned, right? C over A, right here. C over A. So E must be C over A. Okay. So we know the relation between C and A. Okay, C over A equals square root of 2 over 4. Okay, we know B equals 2. But in order to write the equation for ellipse, we need to know A and B, right? So our job right now is to get A. Okay, because the equation is what? Is x squared over a squared plus y squared over b squared equal to 1. We already know b, so we can plug them in, but we don't know a. So our job is to get a. How are we gonna get a? Okay, so we're gonna use the relation between ABC. So c squared equal to a squared minus b squared. Okay, but the thing that we know b. Okay, so we can plug it over here, but we don't know C. But C we can get it from here, right? C we can get it from here. So from here, what we get? We can get C is equal to A square root of 2 over 2. Cross multiply. Okay. So C square equal to what? C square will be equal to A square root of 2 over 2 square equal A square minus B square is 4. Right? Okay. So this is equal to what? Equal to A square over square root of 2 square is 2, square root of 4 square over 2 equal A square minus 4, right? Then from here I can get A, right? I can get A over here. So A will be equal to what? A square minus A square over 2 equal 4, right? Then we're gonna have 1 over 2A square equal 4. Then A square equal 8. A square equal 8. Okay, A square equal 8. That's good enough. Okay, then the equation will be x squared over 8 plus y squared over 4 equal 1. And here you go. We're done. Okay. So that is how you're gonna write equation for ellipse. So it depends on information they give you. You can set up the relation and try to find the value A and B. Okay. All right. So I'm gonna stop the example. I'm gonna stop the horizontal ellipse with the center is at the origin with example number 2 right here. Next, I will be talking about I'm still talking about a horizontal ellipse, but in this case, the center is not at the origin anymore. The center, it will be something else. Okay, it will be something else. So I think I'm gonna put over here is so I'm gonna put over here, yeah, A is horizontal ellipse. I think I'm gonna put 1 instead of A. 1 is horizontal ellipse, and the first case is ellipse with the center at origin. So this is case 1, and I'm going to put A. Okay, so this is number 1. Okay, and this is A, and now I'm gonna do B. Okay, if we have a ellipse with the center is not the origin, okay, then the equation for that ellipse will be x minus h squared, okay, over a squared plus y minus b squared, okay, minus k squared over b squared equal 1. Alright, so I'm gonna box this also. Okay. So in this case, the center, so I'm put the center will be h and k. The center, the coordinate of the center will be h and k. Okay. A is still greater than B. Okay, A is still greater than B because this is still a horizontal one. A is still greater than B. Okay. And the relation between A and C is still the same. So we have C squared equal to C squared equal to A squared minus B squared, still the same. However, you have to be careful with the coordinate of the vertex and the coordinate of the focus of the foci. Okay. I'm not gonna put the formula over here because I don't want you to memorize the formula every time you're dealing with the ellipse which the center is not origin, because I don't want you to learn mathematics by routine. So every time you're dealing with this, I want you to sketch the picture, and from the picture you can get the coordinate of all the vertices and the coordinate of the C. Okay, because right now the center is being moved, so everything will be moved. Okay, everything will be moved. Of course, the major axis is still 2A. Okay, major axis will be still 2A, and the minor axis is still 2B. However, the coordinate of everything will be moved because the center moved. All right. So let's go through the example when we have this type of ellipse. Example number 3. What if I have something like this? Let's say alright. What if I have x plus 1 squared over sorry guys, x yeah, x plus 1 square over 9, okay, plus y minus 1 square over 4 equal 1. Okay, so in this question we want to find major axis, minor axis, coordinate of all the vertices, the coordinate of the focus, eccentricity, directrix, equation of directrix, everything. Okay, we need to try to find everything. All right. Okay. So we know that the major axis is still 2A. So A over here 3 squared, so it will be 2A will be 6, and the minor could be 2b, could be 4, so it's kind of the same. But we also know the center is -1 and 1. Okay, -1 and 1. So what we have from here, so the center is -1 and 1. Let's draw the picture. Right now you're gonna draw the picture. Look at this. So right now center is -1 and 1. So I think -1 right here. So I'm gonna move a little bit. So I'm gonna put the y-axis here. Okay, so this is x, this is y. So center is -1 and 1 here. So this is the center. Okay, and the major axis is, so this is a horizontal. The major is 6, so the a value is 3, right? So it's gonna be here and here. It's a1 and a2. Okay, and the other one is to be b1 and b2. So b1 must be right here and b2 up here. Okay. Alright, so you're gonna graph it, you're gonna sketch, you're gonna draw the ellipse. Alright, you're gonna draw the ellipse. So after you draw the ellipse, and it's very easy for you to write a coordinate of all the vertices. Alright, so this is a -1. Oh, I think I messed it. This is -1 and 1, so it's -1 and 1 is all the way up here. So let's change a little bit. So let's make it -1 and -1. Okay, so let's change the question a little bit. So this is -1, -1. Here you go. Okay. All right. So the center will be -1 and -1. Okay. So we can write the coordinate of the vertices. So a1, the coordinate of vertices could be what? See that? It's not gonna be -3, 0 anymore. But this, because it's moved, so everything will be -1, -2, -4 right here. It will be -4, -1, right? -4, -1. That's a1. a2 will be what? a2 will be 2, -1. See that? 2, -1. And b, this is b2, this is b1. And b1 will be what? b1 will be how many? 1, 2, 3, right? 1, 2, 3. So we will be -1, -3, right? And b2 will be a -1 and what? -1 and 1. Okay. So usually, if we have the order of when we have the ellipse which the center is out of origin, we have what? We will have b1 will be what? 0, 2 and 0, -2, right? But you see that because the center is changed, so everything changed. And when you after you graph, and you can get information from the graph. You can get a coordinate from the graph easily. Okay, all right. Sorry, I'm gonna check the recording one more time to make sure that everything is recording. It's still recording. Very good. Okay, and I can get the center, the focus. We can get a C, right? We know the relation between ABC is that C squared equal to A squared minus B squared. In this case, it will be what? It will be 9 minus 4, so it will be 5 again, right? So C will be what? C will be plus minus square root of 5. It tells you from where? From the center to F1 and F2 is square root of 5 and -5. The distance will be square root of 5. So square root of 2 point something, right? So so F1 is right over here, and F2 is right over here, right? But when you write coordinate, it will be different. So F1 will be what? From here to here is square root of 5. Right? From here to here is also square root of 5. I'm talking about the distance. Okay. I'm talking about the distance. We square root of 5. But the coordinate will be what? The coordinate will be 1 plus square root of 5, right? So it will be negative 1 minus square root of 5, comma, negative 1. Right? Because it's the one component over here will be negative 1. But the x component will be 1, negative 1, and another negative square root of 5. Similarly, for f2 will be what? Will be the coordinate will be what? Over here the coordinate will be, because from here to here is square root of 5, from here to here is square root of 5, but when we write coordinate, we're going to start from the origin, right? So will be what? Will be 1. Will be, let me say, square root of 5. Will be square root of 5 minus 1, right? Right? It's from here to here square root of 5. You minus 1 unit, then it gives you from here to here. Okay? And the y component is still negative 1. Okay. Some of I have to say that sometimes you learn from somewhere, I don't know. I mean, you guys learn from the formula, like something like y minus k and x minus 8, and it's very confusing. Because if you learn like that, I just need to change the name, everything will mess up. Okay, so I want you to grab the picture, then you can get f1, f2 easily. Alright. Alright, so now we can get the eccentricity. E will be C over A, right? So that could be easy. C over A could be square root of 5 over A could be 3. So so this is very easy. C over A. The axis of the equation of directrix could be very easy too. So directrix equation is it won't be changed. The only thing that changed is the coordinate. So this will be x plus minus x equal to plus minus a square over c. So it will be a square will be 9 plus minus 9 over square root of 5. Okay, so this won't be changed. It won't be changed. Okay. Let me check one more time. Let's see. We want to make sure that it won't be changed. Yes, I'm sure. Okay, so it won't be changed because it's just the equation, so it cannot be changed. Okay. All right. Let's see. I can give you the example on writing equation of ellipse, which the center is not the origin or not. Let's see. I can get the example over here now, or I can give you something else. Okay. And I want you to convert it to, I can give you the general equation, and I want you to convert to the equation of ellipse whose the center is not the origin. I can do something like that. For example, something like that. Example number 4. Okay, example number 4. Let's see, I have it or not. I probably don't have it. Okay. Yeah, I don't have it right over here. I don't have it at hand. I can make it up, but I don't have it at hand right now. So I think I'm gonna give you something else. Let me give you. Let me see if I have something on this text or not. Or maybe on another text. Let's see. -1. Let me check the other textbook and see we have more example. When we're dealing with conic curve, then you have to do a lot of example, and that's why I try to give you more example. You know, I can stop right here because it looks like the concept is you got it already, right? But you know, sometimes you need to be exposed to more example. So try to see if I can give you something else or not. Chapter chapter 8.1. Is the 8.1. 8.2 to 7.2. Okay. Sometimes the textbook give you a very simple one, and you know it's kind of hard for you to learn from the simple one, you know. Alright, so how about like this? What if I have something like this? I have the question is so that the equation below represent an ellipse. Okay. And the equation I'm talking about there you go. The equation is 4x squared. Okay. Minus 16x plus 9y squared plus 54y plus 61 equals 0. Okay. Alright, so how we do this? Let me refocus this. This is a long video, really long video. Alright. So it means what? We need to bring it back to either this form or this form, right? Because right now we're doing a horizontal one. So either way, either case. It means what? We need to bring it to perfect square. And remember, every time we try to bring it to perfect square, we need to have it. We need to do complete the square. Okay, we need to do complete the square. Okay, so how we do complete the square? We're gonna remove everything. So I'm gonna keep everything, the x term, y term on one side, and remove the negative 61 to the other side. So my equation become what? My equation become 4x squared. Okay, minus 16x plus 9y squared. Okay, plus 54y. Okay, equal negative 61. So I have to complete the square right here, right over here. All right. So how am I going to complete the square right here? So 4 is, I can write it as 2x totally square, right? And over here is 2 times 2 is 4. It means so I'm gonna take this. Okay, let me see. So I can write this is 2x squared, right? And minus 2 times 2x. Okay, but 2 times 2 does not give you 16, so 2 times 2 is so multiply by 4, right? Okay, multiply by 4. It means what? It means that the b, it means, you know, remember the formula a minus b squared, a squared minus 2ab plus b squared. Then the b will be 16, will be 4 squared. Okay, all right. So if you have 4 square over here, you have 4 square on the other side. I'm gonna add it later. Similarly for this, so yeah, I can write 3y totally square. 54 actually is 2 times 3y, right? 2ab. Remember the formula a plus b square, a square minus a square plus 2ab plus b square. So give me 6, so give me 9, right? 9, okay, times 9, okay. Then times 9 will be, then the last term will be 9 square, right? So we're gonna add negative 61 here plus 4 square plus 9 square over here on the right hand side. So if you're not good at completing the square, then you have trouble with this, but I mean, it's not really that bad. Okay, completing the square, you're going to use the square of the sum and the square of the difference formula back in the day when you learn college algebra. Okay, so right here I can rewrite it as 2x, okay, plus 4 square. All right. And over here, okay, and over here I can write as 3y plus 9 square. Okay, and over here is negative 61 plus 16 plus 81. Okay, all right. So negative 61 plus 16 plus 81, it gives you 36. Okay, and over here we're going to have 2x plus 4 square plus 3y plus 9 square. I'm going to factor number 2 out, so then 2 square will give you 4, so you have 4x plus 2 square, right? Plus factor number 3 out, and 3 square give you 9, right? So we have you y plus 3 square. Right, equal 36. Now what you have to do is just go ahead and divide both sides by 36, because the ellipse equation, they have 1 on the right hand side, so I divide both sides by 36, so I have x plus 2 square divided by 36 give you 9, divide by 36 give you 4, and divide by 36 give you 1. And look at this. This is the ellipse who the center is negative 2, negative 3. Major axis, this is a horizontal ellipse. Horizontal ellipse. There you go. So this is ellipse. Okay. So that is how you show that the equation is ellipse. You have to complete the square. I try to give you another example when we have to write equation of ellipse, but whose the center is not at the origin. But I couldn't find any. Let me see. How about this? Oh, it looks like I can find one. Look like I can find one. Oh yeah, right here. Oh yes, right over here, guys. You got it. Now, example number 5. All right. Let's refocus that. There you go. write equation of ellipse. This is a very long one, very long video. Okay. Which foci at -3, -3. Okay. And so they give us two focus already, 7, -3. Okay. Okay. And goes through point. Okay. 2, 1. All right. So how are we gonna do this? Answer. Maybe when we talking about a vertical one, I'm gonna give you a less example, because I mean, it's gonna be the same, you know. As long as you understand the horizontal one, you will be understand the vertical one. It's nothing hard. All right. So how do we know that this ellipse has the center at the origin, and or how do we know that this ellipse has the center at somewhere else? How do we know? If you look at the focus, okay, let's draw the picture. The focus is -3, -3, so -3, -3 all the way over here. There's 7, -3. So look at this. So this is my y, x, 7, and -3, -3. So 1, 2, 3. So I'm gonna put 1, 2, 3, 4, 5, 6, 7. It's kind of very big one, but I think I'm gonna draw that big. So maybe I'm gonna use. So let's do this. It's 1, 2, 3, 4, 5, 6, 7 right here. So this is my x. So just -1, -2, -3 right over here. So the focus is -3, -3. Oh, -3, -3 is on this side, guys. -3, -3 is on this side. So -3, -3 is right here. -1, -2, -3, and so right here. So this is one of the f. We don't know this f1 or f2. Let's locate the point first. So 7, -3. So 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, -3. So right over here. So over here must be f1. Over here must be f2. The f, look at that. If you connect f1 and f2, it gives you a line, right? And that line is horizontal, is parallel to the axis. It means what? It means that this must be a horizontal ellipse. And the center, because the center of the ellipse is always on the same line with f1 and f2. Okay, so the center must be around here. The center must be around here. Inside here must be the middle point. Okay, it must be the middle point. And you can find the midpoint. Remember, you can find the midpoint, the coordinate of the point, the coordinate of midpoint given two endpoints. I mean, you look at the graph. If you look at it on the graph, you know right away the center must be right over here. Right? So let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5. So the center must be here. You know that on the test, you don't have graphing paper. You get, because I have graphing paper, it's very easy for me to locate the center. But if you don't have graphing paper, in order to find the center of the ellipse, you have to use midpoint formula. So I can find xc is equal to xf. Okay, so 7 plus minus 3 over 2. So it'll be 4 over 2. It will be 2. Right? So you see that? 2. Okay, and YC will be negative 3 plus minus 3. Okay, plus minus 3 over 2 give negative 6. Negative 6 over 2 give you negative 3. So negative 3. You see that? The coordinate of point C. So from there I can get center. The coordinate of the center is 2, negative 3. Graphically, you can locate it on the graph. 2, negative 3. So C right there. Okay, C right there. Okay, the center. I think I'm gonna use because right now at this moment I already use C. Maybe next time I use I, because I don't want you to get mistaken with the C1. The C is the distance between the center and the focus. So so next time maybe I'm gonna use I. So I think I'm gonna change it to I right now. So I'm gonna change it to I. So this is I. So this will be I. This will be I. Okay. So center I. Coordinate will be 2, negative 3. And now I can get C. C is the distance between I and F. So how many? 1, 2, 3, 4, 5. C will be 5. It means that you can find A and B, right? If you know C. Anything else we can find A and so that we can find A and B, because we need to find A and D. Okay. Right now I can get the equation. So we know the equation will be what? The equation will be x minus 2 square over a square plus y minus it's kind of dark on that side, right? I don't know why. Let me fix the line a little bit here. Okay, so y plus 3 square over b equal 1. And we know another, so we know what? We know the ellipse goes through point 2, 1, right? So I can plug 2, 1 over here, so we can have 2 minus 2 square over a square plus 1 plus 3 square over b square equal 1. So this is 0. So 1 is for 16 over b square equal 1. So b square equal to 16. So b equal 4. Okay, so you get C, you got B. Can we get A? Yeah. So C square is A square minus B square. So A square will be C square plus B square, right? So C square is will be 25 plus 16, which give you what? It gives you 41 is A square. So right now I can write the equation will be what? The final equation will be x minus 2 over square over 41 plus y plus 3 square over 16, right? Equal 1. And this is the final answer. Okay. With a little bit of sketching, you don't have to use it, or you don't have to graph the whole ellipse unless the question asks you to graph the whole ellipse, then you can. But if just a little bit of sketching and locate the point, you know right away that this is horizontal ellipse, and you know right away that this how you're gonna get A, B, and C. Okay. So if you want to sketch, so I can sketch it really quick right now. So B is 4, right? B is 4. B is 4. I mean, this is 1, 2, 3. So it's gonna be up here. So this is B2 up here. And 1, 2, 3, 4. Oh, B is the whole thing. I'm sorry. 2B, so B8, yeah, B4, yeah. So this B1, yes. Okay. Okay, so that's B1 B2. What is A? A is kind of hard because A 41. So you take square root of 41, which is give you 6.4. So we have about 6.5. So we have 1, 2, 3, 4, 5, 6. So 6.5 right over here. So that is your A2. So 1, 2, 3, 4, 5. Then 6 is 6.5 right here. 6, 5, 5, 6, 6.5. So A2 right here. A1 right here. Alright. And now, if you want to sketch, here you go. You want to have the ellipse. This is the ellipse. Alright. This is the ellipse. I try to be perfect for you guys, you know. Here you go. Here you go. Wonderful. That's beautiful ellipse. Here you go. So there's A1, there's A2, there's A1, F, B1, B2, center, everything. Okay, you got ABC, then you can get axis of the. We have a eccentricity if you want to find. You can find the Directrix equation if you want to find. But because over here they just ask you to find right equation, so this is what it is. All right. Okay. So I think I'm gonna stop over here. I think I have to divide 2 more video because right now I already talked about the horizontal one already. So in the next video I will be talking about the vertical one. So I'm gonna stop right over here. Okay, and then in the next video I will be talking about the vertical ellipse.